Hey everyone, okay, last video for the 2019 semester review. What are we doing? We're going to go where I left off, so we're going to go to number 26. These three, you can see I stuck with sine, cosine, and tangent, not the cosecant, secant, or cotangent. And what lesson did these all come from? Remember? This is lesson 8.6, so if you want more practice or you want to see more of these, you can go to your 8.6 practice. Okay, well, let's do number 5. All of these trig functions are by themselves except for a plus or minus, so we need to just move this term to the other side. So this is a 5, so we're going to subtract 5. But when I subtract 5, I need to have a common denominator with 2. So I'm going to say minus 5 times 2 over 2, like that. So I made the common denominator, but I'm still subtracting the number 5 because 2 divided by 2 is 1. All right, so we're going to have cosine of theta equals 10 plus the square root of 3 minus, what's 5 times 2? 10, right? Because we have a common denominator. All right, what's 10 minus 10? Combine like terms. Those go to 0, and we're left with the square root of 3 over 2. Now what we're going to say is where on the unit circle is a cosine equal to square root of 3 over 2? Some of you guys can do that in your head, and that's pretty cool. Others, we need to create a mini unit circle. Let's be official here and write theta will equal the arc cosine. So the arc cosine is where is the cosine equal to that. Okay, here's how we create a mini unit circle. We go 1, 2, 3, 1, 2, 3, and cosine is which value on the unit circle? It's going to be the x value, so we know that we're looking at this angle here, where the x value is square root 3 over 2. And that's our small radian, and that small radian is pi over 6. So that is the part, pi over 6, where you have to have memorized. Hopefully you all know how to count to 3. 1, 2, 3, 1, 2, 3. That was easy, but then the pi over 6 you have to have memorized. Okay, this cosine, this square root 3 over 2, is that positive or negative? This is positive, right? So our x value is positive, and our x value is positive in quadrant 1, and what other quadrant? Quadrant 4. So our thetas will equal pi over 6, and then pi over 6 down from 2 pi. So this little angle up and this little angle down is, what's that going to be? 11 pi over 6? Yeah. Okay. You can check the answers. So same thing with these two, except one's sine and one's tangent. So on the test, you guys, you'll have a sine, cosine, or tangent. What did I leave out? Did you guys notice what I left out? Is there any junk in here with the thetas? Any junk in there? No, they're all by themselves. Okay, so it's a one-stepper. Move something over and then solve, and I think that's a pretty good question, pretty fair. All right, let's go to function operations. Function operations, and it looked like 30 was the most complicated, but I can talk about 28 if you want. All right, so to do this, we're going to go, you always evaluate from the inside out. So on 28, you take negative n and plug it into f here, and then you take that answer and plug it into the n for the g function. Okay, what do you do here? We're going to plug in 2t into both and then subtract. You got to make sure you distribute that minus sign on the h. All right, but this one has a lot going on, so let's figure out what's going on. Let's do 30 together. Here we go. So this says find negative 4 times h of 3n minus 2 times g of 3n. So what we really need to find first is h of 3n and g of 3n. So I'm going to do that first. Okay. So h of 3n, the n here was replaced with 3n on the left side, so I'm going to replace the n on the right side with 3n. You will be doing this in any math class you take next year. calculus, pre-calculus, Math 4, MRWC, this is very, very, very important. Okay, that's h of 3n. Yeah, that's it. Take the n out, replace it with 3n. Okay, let's find g of 3n. So g of 3n says, well, g of n is n squared. So instead of n squared, we're going to do 3n squared. It's just substitution. Oh, Miss Keener, it's just substitution? Yeah, it's just substitution. That's it. There, I zoomed out. See how it was n squared? Oh, stop it. Stop it. Okay, ready? N squared. And now it says 3n squared. But it's not 3n squared, it's 3n quantity squared. You want to sound like a hardcore mathematician, you say 3n quantity squared, which really means what? 9n squared. Where'd the 9 come from? 3 squared, yeah. All right, now what are we doing with these? Question, find -4 times h of 3n, and then do -2 times g of 3n. Here we go. -4 times h of 3n. So h of 3n is 3n minus 4. And then -2 times g of 3n, 9n squared plus 5. So we started with some substitution, but now all we have to do is distribute and combine like terms. So here we go. -4 times 3n is -12n. What's -4 times -4? Positive 16. -2 times 9n squared. And then -2 times positive 5. Do you remember math used to be like this? Do you remember when this used to be hard? But now doing it, it's like, oh, I like this. Okay, combine like terms, and we're going to put the exponent, the highest power in the front, n squared, and then I see these n's, and then combine the constants together. So we have a 16 minus 10, and we have a plus 6. That's not a 6. Let's see. Ta-da! Now it is. And I'm going to check my answer. I hope I didn't mess up. Got it. Awesome. Okay, so you practice the other two. Okay, extra credit. These are called, ready? These are called complex fractions. Complex fractions. And there's long ways to do it, and then there's a shortcut way to do it. And if you want to get the answer right on a calculus test, you need to be able to do the short way because you need time. As you guys grow up and go through math class, you don't have unlimited time. Okay, so you need to learn how to do fast ways. So, do you all remember greatest common, not greatest common, that's wrong. Just a common denominator, okay? But I think that's called least common multiple, but I never taught middle school. So, what would, if you look at all of these denominators, what would the common denominator be? We have y squared, we have 4, and we have y. It would be 4y squared. I think it is least common multiple. 4y squared. Now, the shortcut is to take the numerator and the denominator and multiply it by the least common multiple. And when you do that, you take your complex fraction and in one step, you go to just a regular fraction with a numerator and a denominator because all the denominators will cancel because you made sure that all the denominators are represented in this 4y squared. Okay. This is a game we like to play called What Cancels and What Stays. You ready? Here we go. In the top. What cancels? Y squareds. Good. What will stay? 4 times 4. What's 4 times 4? 16. All right. Now we're going to distribute this. So here's our game. 4y squared times y over 4. What cancels? The 4's. What will stay? y times y squared. What's y times y squared? If I put it here, maybe that's a little easier. The 4's can cancel. Yeah, okay. Minus, we have a minus sign, don't lose that. Over here, what cancels? 1y cancels. So then what will stay? 4 and a y will stay, and an x squared. What would be the best way to write that? 4x squared y, like that. Do you see how in one step, how that's simplified? And we're done. That's it. Do you want to do another one? Let's do 33. Okay. In one step, what would cancel everything? What's the one thing? Now you can't do, you guys, hi. You can't do v squared here and u here and 6 here. Like you can't do different things. That's the trick, is that it had to be the same thing on the top and on the bottom. So what would be the least common multiple that would make all your denominators cancel? U times v squared? Yeah. Math is logical, so we logically put the letter that comes first in the alphabet. We put that first. Okay, you ready? Here we go. So what cancels and what stays? I love that game. Do you guys like playing that game? What cancels and what stays? So in the top, what cancels? V squared, and we have a u squared times u. What's u squared times u? U cubed. All right, 33. Oh, sorry, denominator down here. This u cancels with this u, and what stays? 4v squared minus. Okay, what cancels? V squared, and what stays? 4u squared. That's it? That's it. Can you cancel these u's here? No, you'll get 0. I don't care if you spent 10 minutes on this and you canceled everything right. It's extra credit. It has to be perfect. You cannot cancel these u's because of the minus sign. All right. Okay, let's see. I have a couple more minutes. Should we look at 21? These had a lot. Now, if these are, each question's worth 5 points, okay? Your goal is to get most of the 5 points. But if you just bomb on one, that's okay. Maybe you can do some of it, okay? Maybe you can get some of the things done. But this question will be equally weighted to this question, okay? All right, just FYI. Step 1, factor first. So on 21, let's factor first. Always factor first. So we have x times x multiplies to get -4, but adds to get -3. And then here, remember greatest common factor? What's the greatest common factor here? 2x. And then, let me do that here. Are we going to have to factor again? No, we're not. I thought maybe we'd have a difference of 2 squares, but we don't. All right. Good morning. Does a factor cancel? When a factor cancels, what does that give you? A whole at 4. Do you remember, how do you find the y value of the whole? How do you find the y value of the whole? We plug 4 into the leftovers. So when you plug 4 into the leftovers, we get 4 plus 1 is what? 5 over 2 times 4 is 8. Fantastic. There's our whole. All right. A vertical asymptote comes from the factor that doesn't cancel, and that would be right here, 2x. Is that adding or subtracting anything? No. So do you remember what is going to go there? X equals what? 0? Okay. Our zeros come from the numerator that didn't cancel, so that would be x equals -1. Are we supposed to find a y-intercept? All right, my time's running out. Plug in 0. Uh-oh. So undefined. No y-intercept. because there was an asymptote